In the realm of aerial warfare, the U.S. Air Force has long been a leader in technological innovation. However, this leadership comes with environmental challenges. As a notable consumer of fossil fuels within the U.S. Department of Defense, the Air Force is now turning its focus towards sustainable aviation solutions. That's where JetZero comes in. This startup is collaborating with the Air Force to develop a prototype blended wing-body aircraft, a design that could be a game-changer in both military and commercial aviation. The aircraft aims to significantly reduce fuel consumption while potentially extending flight ranges, a crucial factor in modern warfare scenarios. As the climate crisis continues to escalate and geopolitical tensions with China intensify, the importance of this new aviation technology cannot be overstated. JetZero is not just developing an aircraft, they're working on a solution that could balance military needs with environmental concerns. The prototype could very well set the standard for the next generation of aircraft, both in the military and beyond. Blended wing body, or BWB technology champions, like JetZero, argue that the traditional aircraft design we're familiar with is archaic and far from optimal. This standard design, the iconic tube and wing fuselage predominant in modern airliners, isn't just outdated, it's a hindrance in a world grappling with dwindling resources and escalating global temperatures. Enter the blended wing body design, a revolutionary approach that harmoniously integrates the wings and fuselage into one unified fluid structure. The outcome, an aircraft with a smooth, uninterrupted surface, dramatically slashing aerodynamic drag. This allows air to flow more efficiently around the plane, revolutionizing our notion of aviation design. With its cutting-edge contour, the BWB can transport more passengers and cargo within the same wingspan. This means heightened aerodynamic prowess. But that's not its only merit. One of the standout features of the BWB is its immense promise for enhanced fuel efficiency. With reduced drag, the engines have less strain to sustain speed, translating to decreased fuel consumption. The expansive internal space also grants flexibility in weight distribution and fine-tuning the aircraft's center of gravity. This is no mere tweak in design. The BWB stands poised to redefine efficiency, delivering significant fuel savings over its conventional counterparts. While the blended wing-body aircraft might seem avant-garde today, it's far from a novel concept. For decades, the allure of simple manufacturing methods and perceived practicality nudged this groundbreaking design into the shadows. Moreover, a tragic incident early in its history may have profoundly deterred its widespread adoption in the early 20th century. Nicholas Voyevodsky, in the 1920s, was among the first to theorize the potential of the BWB. Buoyed by promising wind tunnel tests, the audacious Westland Dreadnought prototype was crafted, heralding a potential revolution in aviation. The prototype came early in the history of aviation, promising a marked shift in the industry based on the Dreadnought's performance. However, on its maiden voyage, the prototype stalled unexpectedly, severely injuring its pilot. Shaken by this misfortune, Voyevodsky abandoned the endeavor, inadvertently shelving the BWB's promise. The aviation community pivoted, fixating on tube-like fuselages, conveniently sidelining the superior fuel efficiency that the BWB blueprint pledged. A fleeting resurgence of the concept took place in the 1940s with the Miles M26 airliner project. The Miles M30, or X-Minor prototype, was forged to explore its potential fuel-saving prowess. Regrettably, these tests didn't conclusively champion the BWB, crippling its broader adoption. A closer inspection revealed that the M30 X-Minor suffered design limitations. Specifically, its diminutive size meant it couldn't house buried engines, leading to suboptimal test outcomes. Likewise, the McDonnell XP-67, another BWB attempt, debuted in 1944, only to fall short of expectations. Post-World War II, aviation consensus crystallized around the conventional tube-like fuselage. However, the BWB spark wasn't entirely extinguished. Fast forward to the 1990s, NASA and McDonnell Douglas revisited the vision with the BWB-17 model. Developed by Stanford University, this 17-foot marvel flew in 1997, showcasing exceptional agility and energy efficiency. NASA's partnership with Boeing on the X-48 unmanned aerial vehicle further validated the BWB's merit. Research indicated that a BWB airliner with a 450 to 800 passenger capacity could slash fuel consumption by over 20%. Today, in the 21st century, there's palpable excitement around the BWB in aerospace circles. Yet, a pivot to this design is fraught with challenges, from overturning entrenched manufacturing protocols to revising global infrastructure norms. Embracing the BWB would be transformative for commercial aviation and, by extension, the world. But it mandates a reimagining of global airports, given the BWB's unique specifications. With our airports tailored for the familiar cylindrical fuselage, this shift, though revolutionary, would undoubtedly demand a complete architectural rethinking. While the U.S. Air Force has historically emphasized technological edge, broad reach, and lethal capability, recent moves suggest an emerging emphasis on sustainability. JetZero's recent contract for a military-centric BWB prototype underscores the USAF's recognition of the dwindling global fossil fuel reserves and the strategic implications of this reality. The move also puts BWB Design well inside the focus of military planning. This development will surely catapult the emerging technology even further, as previous attempts at honing the BWB technology centered around their impact on the airliner industry. The promising new prototype JetZero was tasked to produce will be a military platform. This cutting-edge aircraft is earmarked for assembly by 2026, with inaugural flight tests anticipated for the following year. The project is part of a larger vision, ushering in the next generation of fuel-efficient, eco-friendly aircraft for the Air Force, a necessary shift given its current status as the Department of Defense's largest fossil fuel consumer. Interestingly, the BWB project isn't just about efficiency. It has broader strategic implications. The prototype holds potential lessons for the next-generation air refueling system initiative and upcoming refueling endeavors, especially considering the Pacific Theater, a region increasingly defined by its geopolitical tensions, particularly with China. The USAF has asked JetZero to prioritize long-range capabilities, as well as short takeoff and landing features in the demonstrator prototype, as it will be used to shape a new generation of combat aircraft designed to excel in a possible war in the Indo-Pacific. At the same time, the other goal of the BWB endeavor is to achieve fuel savings of up to 50%, a leap from conventional tube and wing aircraft. Financial backing for JetZero's ambitious undertaking is robust, with the Air Force committing $40 million in 2024, matched by private stakeholders, culminating in a 5-year commitment of $230 million. Driving the prototype will be geared turbofans, a brainchild of Pratt & Whitney, strategically positioned atop the rear fuselage. While the BWB's conceptual roots trace back to the 1920s, the Air Force asserts that recent technological breakthroughs have made its mass production feasible. The project is a collaborative effort by the Department of the Air Force, NASA, and the Pentagon's Office of Strategic Capital. Success in this venture promises an Air Force fleet with a minimal environmental footprint and heightened strategic prowess, tailor-made for the complexities of warfare in the 21st century. With unparalleled aerodynamic finesse, unmatched operational distances, and adaptability to compact airstrips, the next-generation aircraft, spearheaded by JetZero, could offer the USAF dual superiority, an edge over geopolitical rivals like China, and a proactive stance against the looming specter of climate change.